Hello.
Hi.
Hello, everybody out there in TV land. This is Jonathan Morgan in Seattle, Washington, reporting for the Learning and Evaluation team of the Wikimedia Foundation. And although I can't see you, hopefully you can see me and hear me. Today we're going to talk about some Wikidata research tools and methods, and it'll be easier to follow along and learn if the audio and visual are working. So if you're having trouble seeing or hearing me at any point, please do post in the Google event page for this event and let us know, and we'll try to fix that issue. Without further ado, let me begin. Sorry, Maria Cruz, my associate in Buenos Aires, Argentina, is here as well.
Hello, everyone.
Hi. Is this... I'm hearing myself on a delay now. Is anyone else hearing that? All right, that's better. I had myself playing in another tab. I started to hear myself on a 30-second delay. It was very confusing. Anyway, let me get myself started here. I'm going to share my screen and go through the slides. The slide deck link is posted on the event page, and it's also posted on the wiki page for this webinar series, which itself should be posted on the event page. Let's see. Are these things fun? There we go. All right. So, today I'm going to talk about some of the tools that are available for us to do various kinds of on-wiki research stuff beyond the Wikimetrics tool that the analytics department is developing in collaboration with grant-making. The purpose of these talks primarily is to, for anybody in the Wikimedia community, but particularly people who are doing programmatic research or trying to answer questions in the scope of a grant or some kind of project aimed at improving our movement, growing our movement, to demystify the research process and the amount of programming necessary to ask and answer questions with data. These sessions are also meant to provide a starting point for your independent work. So I've started to collect a list of resources on Wiki that will help you move forward from this. Unfortunately, it's difficult to actually teach somebody how to program or how to manipulate data directly in a format like this. I've done some workshops face-to-face that do that a little better, but from here I think we're going to be working primarily at giving you the tools you need to get started. And so this first intro session, the first of 3, is going to provide an overview of data resources and research resources, and there won't actually be hacking involved. And finally, we're eager to find out what you think and find out how many people attended this. So Maria has posted a link to a survey on the event page, and if you could fill that out before, during, or after this presentation, we'd be very appreciative. So first, an overview of what this talk is going to be about. I'm going to talk about how wiki research works, provide a quick overview of the kind of data and tools that we have, and then I'm going to go into the MediaWiki API and the MySQL databases. There are 2 primary data resources, and explain what they are, what they're good for, why you might use them, and a little bit of how you might use them. And then I'm going to go over some of the prep for next session, which unfortunately will be a month or more from now in late August because we have Wikimedia coming up, which puts a monkey wrench into everybody's plans in a good way. First, how wiki research works. This is pretty rudimentary stuff. One of the important things I think to think about here is that most people who are learning how to use data to benefit their community don't have the opportunities that we have. And we have these opportunities because our data resources are public and they're provided under free licenses. So the Wikimedia Foundation and the Wikimedia movement, oh, excuse me. Sorry, I had to switch to a different view. Hopefully you're all still able to see me. This data is made free and freely available so that people can build tools that use it. Hold on just a second. I'm trying to get my slideshow viewer to work so that these slides are presented in full screen mode. I'm going to mute myself for just a second. Sorry for the delay. All right. We're trying to share the slides in a presentation mode, but that's not working. So I'm going to go back to share screen, and we're just going to share the browser window again. Sorry about that. Technology is fun. All right. And so the community and the Wikimedia Foundation have created tools to make that data useful, which allows us to ask and answer questions. And that's wonderful. And I always think that's cool. I learned how to program and learned to be a researcher on Wikimedia data, and I'm always grateful for that. What kind of data is available? Basically, we have primarily edit logs. So almost every action that results in an edit will be available publicly for people like you and me to manipulate and study. We also have some degree of page view data, although it's imperfect and not always reliable. And we have some location data for run registered editors who are identified by their IP address. And that's primarily the data sources we're working with. We do not have personal information about editors available publicly. We also don't share the content of deleted revisions publicly. And we don't have any universal way to measure quality, which I include specifically here because people always want it, and I have to tell them that there's no good solution for that yet. And we don't share any kind of Google Analytics type data publicly, so you can't see who migrated, who navigated to a Wikipedia page, and how long they stayed. what the tools we have are APIs and databases, and we'll get to these in a minute, and lots of really great bots and web tools created by Wikimedians. And then a couple of excellent web tools created by the Wikimedia Foundation, such as Wikimetrics. Wikimetrics, as most of you who are watching this, whoever you are out there, know, works by allowing you to gather editing information about a list of users called a cohort. So if you're given a list of users that you want to find information about, you can upload that list into Wikimetrics, and it can give you information about the edits they've made, the pages they've created, the bytes they've added, how long that they've survived, etc. And this can be very useful. And it's useful for online data analysis purposes, and also for offline analysis. So if you have people coming to an edit-a-thon, you gather their usernames and you feed that into Wikimetrics, and you have an idea of what they did afterwards. The way Wikimetrics does this is it queries the Wikipedia database using something called MySQL. So you'll sometimes hear it pronounced SQL or MySQL. MySQL stands for a structured query language. So Wikimetrics queries the Wikipedia database using MySQL, and then it provides you with the results in a nice friendly format, like a comma-separated value or CSV file. Now, you can do this yourself without Wikimetrics as well. And there are some reasons why you might want to do this, some circumstances in which Wikimetrics might not actually fill your needs. For instance, what if you want information about a cohort of editors that Wikimetrics doesn't currently provide? An example of this might be you want the number of edits by members of a cohort to featured articles on the English Wikipedia. Currently, there's no way to get this information directly through Wikimetrics. Also, what if you don't have a cohort yet? For example, what if you want information about new editors who played the Wikipedia adventure? You have to get those usernames before you can feed them into Wikimetrics. And in a case like this, you will want to go to the source, the database itself. So these MySQL databases I just mentioned, there are a couple of basic concepts to grasp here. And this, since the purpose of these webinars is to demystify programming and research, I'm going to define some stuff that's pretty basic for some of you. I'm sure that some people are already familiar with concepts like databases or APIs, and with the terminology I'm describing here. But I've got to start at a kind of basic level to make sure that everybody who wants to learn something from this has the opportunity. Caveats aside, a database consists of one or more tables of rows and columns. So you can think of that in terms of say a spreadsheet, like an Excel spreadsheet or a LibreOffice spreadsheet, with rows and columns and data in every cell. Each row is a data point. So, for example, a revision to the English Wikipedia would be expressed in a row, and each column, each cell within that row contains information about that data point. So, for instance, for a revision to the English Wikipedia, you would have the revision ID, the time and date it was made, the page that it was made to, etc. An SQL query is a command that lets you select what data points you want. So, given that there's a lot of revisions in the Wikipedia database, if you want to get revisions that were made by people who played the Wikipedia adventure, you're going to want to filter out a whole lot of other stuff. SQL is actually a programming language that databases, which means servers or computers, understand. And it's also a relatively easy programming language for people to understand. And I'll give you an example of that. So here's an example of an SQL query. Select page title from enwikip page, where page latest is greater than 2014-07-16-00000000. And this actually should be. So all this query says is, computer, please give me the names of all the Wikipedia pages that have been edited today. Where today is July 16th, 2014, and these 6 zeros at the end here just mean starting from the very first second of the very first minute of the very first hour of today, according to Greenwich Mean Time. So you can see that this kind of query is actually somewhat human readable. It looks kind of like a sentence. Here's another fairly simple query that also looks kind of like a sentence, and I've highlighted some of the syntax of that sentence here. So in this case, I'm saying select distinct. So give me unique results, no duplicates. Rev user text, which just means username. From, and this is the name of the database that I'm querying, where I want to get those usernames from, and wikip.revision. Where rev comment, the comment that you put in when you make an edit, is like Wikipedia Adventure with some of these little percent signs around it, and then limit 10. So the translation of this is, computer, give me a list of 10 users who have played the Wikipedia Adventure. Going back to it, you should be able to see kind of where that's coming from. The users here are these usernames, which is rev user text. You're looking in the revision database, and then you're looking for revisions where the rev comment has something like Wikipedia Adventure in it. And we know those are Wikipedia Adventure edits in this case, because whenever you make an edit through the Wikipedia Adventure game, it automatically gives you an edit comment that says this edit was made as part of the Wikipedia Adventure. And since there are a lot more users who have played the Wikipedia Adventure than we care to look at right now, we want to limit our query to just 10 of them. So that's just an example of what you can get with a simple query. Now, that query just looked at one table in the database. But you can actually, there are many different tables in the database, and you can get more interesting information when you query several of them at the same time. And this is, so this idea of joining tables is a programming concept, or a database concept that I won't have time to go into in too much depth here, but I'll try to get you started with some of the basic components of it. First, each table in the database contains data points, remember, thinking of it as cells in a spreadsheet, about different kinds of stuff, but it's all related to edits on Wikipedia. The revision table, which we just queried, contains rows of information about revisions. There's also a user table, which contains, each row is a user, and provides information about those users, such as the number of edits they have right now, the date and time they joined, etc. You can pull table data from multiple tables by joining in your queries, meaning that if there's some data about, say, user Okasi that's available in the user table, and there's also a list of the revisions that he's made to Wikipedia in the revision table, I can grab all of that information in one query. So here's an example of a query with a join in it. So this is actually the same query we did before with a little additional information. First, we're still selecting the usernames of people who've played the Wikipedia Adventure from the revision table. But we also want to get another piece of information that's not stored in the revision table. We want to get their edit count, and that's stored in the user table. Every one of us who has a user account, there's a field in our row in the user table that says how many edits we have right now, and that field's updated all the time as we make more edits. So we're selecting the rev user from the revision table, and then we're joining on the user table, because we know that each revision contains the name of the user. Oh, this is actually. Each revision contains the name of the user who made that revision, and in the user table, there's a row for every different username. So we know those pieces of information are the same, and we can use that to gather the user edit count from the user table. So this is just one other example up here. There's links in the documentation about some of these database concepts, and you can use that to follow up. But this just gives you an idea, I think, or I hope, of how you can use the databases to ask some pretty complex questions and do a lot of sorting, searching, and filtering in a relatively person-readable format. So this query that I just showed adds to our previous query. Give me a list of 10 users who played the Wikipedia adventure, and also give me their current edit counts, which we're getting from the user table. So that's the database. Let's move on a little bit to the API. So the databases, the Wikipedia databases, which are available on Tool Labs, are one of our publicly hosted data resources. The other one, which is in fact even more public and even easier to access, is the MediaWiki API. So API stands for an application programming interface. And that's always seemed like a fairly vague title to me. I'm not sure that it's all that descriptive. But basically, for our purposes, you can think of an API as a set of rules for how different websites or applications pass data back and forth to each other. And our API is open, meaning that you don't have to have any special privileges to get data from it. You can ask the MediaWiki API for data on things, and it will give it to you without having to, log in or get some kind of special credentials. And the API is also very well documented. Unlike many APIs out there on the internet, our API has some pretty exhaustive and high-quality documentation on MediaWiki.org. So if you go to MediaWiki.org/wiki/API, you'll see that there's a lot of information up there and some pretty good examples as well. So what does the API do? What is the API for? Well, I remember I said that it's a way for different programs or applications in different places on the internet to pass data back and forth to each other. So to give an example of that, I'm gonna show this replay edits tool that the Wikimedian Jeff Paul created as part of an individual engagement grant. So this tool allows you to kind of show a video of edits to an article over time. So if you put an article in there and then click Show History, you can actually see here's the page that was created. This is a very short article with a very short history. And you can see as new contributions are made and deleted to the article over time, and references are added and things like that. So it allows you to show how an article has grown and changed over time. And now we have a nice little stub. So that's all very nice and pretty. How does this do it? Considering that this application it's not a Wikipedia website. It's hosted on GitHub.io. So how does it actually access the data to run that little movie? Well, what Replay Edits does is it uses the API. First, it asks the API for a list of revisions to the article that you just typed into the text box. And then it queries the API over and over again for the text of those revisions, allowing you to basically it rebuilds the article diff by diff in front of your eyes. So this is a great example of how the API can be used, for fun and profit. But you don't actually have to. APIs are useful even if you aren't building a website. They're also useful for gathering data. And in fact, you can access the API and get data from it just from within your browser. And that's called an API request. And it looks like this. Not particularly readable, kind of scary, but we can break this down in a minute. Basically, what this API request, which just goes in the browser bar, is asking is, give me the text of this diff on this wiki page. So if we show it here, I just copy pasted that into the browser, and you can see that it's giving us some kind of data structure. There's a lot of markup here. But then within that, we do have what looks like a section that was added to a page in a revision. And in this case, it's a question asked on the tea house. So this is a way of getting data back from, getting data about a revision without copy pasting. And there's a lot of powerful things that you can do with this, but the text of articles is not actually available in the database. So one thing that if you do want to, say, grab the text of articles and do something with them, search them for particular words or figure out or look at them and see, evaluate their quality, if you want to do that in some way off of Wikipedia, the API is the way to go. The API is actually useful for a lot of things other than just getting text of articles too. It also is a great way to get other information about a page in a structured format that you can then use programming languages or software tools to manipulate. So here's another example of an API request, and this one just gets all the images page for Seattle. So you see in this case, it's giving us some other kind of strange data structure with lots of markup and formatting and brackets. And I'll go into this structure next lesson. It's called a JSON object. But for now, the important thing to see is that we have a list of file names that were returned from this API request. And these are all of the images that are on the Seattle page. So if this is a better way of getting the images on a wiki page than going to it and counting. This example also gives us since it's a simpler example, it also gives us the opportunity to figure out some of the syntax of an API request. So an API request is another kind of computer language. It's a way of asking a computer, a server, a database for data, and it has a syntax that's also somewhat human readable. So in this case, I've highlighted in red the parts of the API request where you're telling the computer what to do, or if you're more polite, asking it to do something for you. First, there's the action, and there's various kinds of actions you can do through the API. You can edit through the API as well, but we're just going to be talking about a particular kind of action, which is a query action, where you're asking the API for data. And then there's an ampersand, which says, it basically says, in addition to this action, we also want to give you some more information. And the next piece of information we're passing is titles, and it knows that means go to look for wiki pages in the main namespace with this title. And then we're asking for particular properties of those pages. In this case, we're asking for images on those pages. And the kinds of things that you can put after these equal signs, the kinds of things you can put after titles or prop, that's all defined in the API documentation that I showed you earlier. So you can't just make up anything and kind of expect it to work. And then you can say what kind of format you want your results returned in. And I got them in JSON this time, but we'll talk about JSON next time. Basically, there's lots of different ways to structure and store data. And there's various reasons you might want to do one over the other. We'll be working with JSON in the next lesson when we start to learn a little bit about how to play with Python and data munging. So here's another API query that you can make. This one gives us some up-to-the-minute information. And one of the things that the API is better at than the database is giving you up-to-the-minute information. And I'll talk about that in a minute. But basically, what we have here is I just asked the API to give me the 20 most recently added articles to the category women scientists. So the API captures when a category is added to an article, and that information is retrievable. So I can see at what rate different articles are being added to a category, which might be useful, say, if you had a bunch of people working in a particular wiki project or in a WikiEd program and wanted to get a sense of the recent changes that they were making. If you knew that they were working in a particular category, you could see it at how articles were being created in that category or added to that category through the API. And this is another, I've highlighted the syntax here, and you can look over the slides afterwards if you're interested to see how we do this. These examples are also listed in the wiki page documenting these lessons. And I encourage you, because it's easy to get started with the API, to play around with different examples and see what kinds of data you might be able to get, even if you're not sure what you would do with it yet. And finally, here's another API request. This one is getting information about users. So I asked for a list of 4 user IDs, Benjamin Mako Hill, JC Morgan, Okasi, and SJ, and I asked for their edit counts. And I see that by default, I get their user ID and their name, but I also get how many edits they have. And we see that Okasi and SJ are, and this is on the English Wikipedia, you can see that Okasi and SJ are leaving me and Mako in the dust. Surprise, surprise. So this example, actually I put in to make a bigger point, not just about my edit count, but you can get a lot of the same information from the API as you can from the databases that I discussed earlier. The databases with all the tables for pages and users and revisions, etc. So under what circumstances would you want to use the API or the database tables? What are these two overlapping resources good for? So there are a lot of different reasons why you might want to use an API versus an SQL database. But here are a couple of the ones that as I thought about this, I thought would be most useful for us, for the kinds of things that we are doing, the kinds of data gathering and data analysis that we're doing. So the API often limits how much data you can get in a particular query. And if you want to get lots of data, the databases are potentially a better solution for that. So if I want to select all the revisions on the English Wikipedia that are made by anonymous editors, that's going to be hundreds of millions of lines? I don't actually know. A lot of data. That's something that you could theoretically get through the API, but you definitely want to use a SQL query against the database for that. I showed you a little bit about joins and how you can kind of make queries that allow you to get something that meets certain conditions but not other conditions, and you can get pretty detailed with it. To some extent, you can do that with the API as well, especially if you are using the API alongside a programming language that lets you query the API multiple times and then search and sort your results. But in many cases, if you want to say get members of a wiki project who joined Wikipedia within the last year and who have over 10,000 edits and who have made at least one edit to the category llamas, then you would probably want to use SQL. Another reason you might want to use SQL is if you want to dump your data straight into a CSV file and then play with it elsewhere, such as in Wikimetrics. And the reason for that is primarily that there are a lot of great software, desktop software tools for Linux, Windows, and Mac OS X that allow you to log into a database like the ones we have on Wikimedia Labs, query it, and then all from your desktop copy the results to a CSV file, which you can then upload to Wikimetrics or do what you want with. So it's a pretty seamless experience and something I actually do all the time. And because these tools, these good open source tools exist, that makes for a pretty handy workflow. And also, you would want to use the SQL, rather you'd be able to use the SQL databases if you have a WMF Labs account, which anybody can get, but it's actually a little bit challenging to figure out how to get set up on Labs. So I've included a couple links to getting started on Labs in the Wiki Research Webinars Wiki page, which contains the links to all the other documentation. And if anybody has better links or additional links, please add them there. Because for the next session, if you want to kind of participate and do more than listen in, you'll have to have a Labs account set up. And it's a multi-step process. So anyway, okay, so now to look at it the other way, what do you want, if you want to use the API, when would you want to use the API rather than the databases? Well, first, you want to use the API if you need up-to-the-minute data. So the databases that we have access to for research purposes, sometimes they lag a little behind the live Wikipedia. So if I were to make an edit to a wiki page right now and then right away query the database and say, give me the most recent edit by user JT Morgan, it might not show that that edit that I just made, because there's often what's called a replication lag. So that's generally not the case with the API. So if you want up-to-the-minute data, use the API. If you want page text or expanded templates or anything like that, you have to use the API because that data isn't available on the databases. And if you want to use your data in a program, like an application such as replay edits, you probably want to use the API. And I put an asterisk there because you can actually use the databases if you want to use your data in a program too. But in most cases, if somebody's building a software application that uses Wikipedia data, they're using the API. All right, so I feel like I've said said the acronyms API and SQL a lot today. Hopefully that didn't deaden your ears. Let's review a couple of the things that I covered today, and then we'll have a little bit of time for questions if people have questions. And I'll also go over kind of what's next and where you can get help and where you can ask questions and what to expect at our next session. First, review our API and our MySQL databases are publicly available tools for manipulating data. And that data is generally data related to edits to Wikipedia and other media wikis. These tools, the API and the SQL databases, are more challenging to learn than something like Wikimetrics or, say, a tool like a Magnus Mansky tool like CAT-SCAN. But they're also much more powerful. And the reason they're more powerful is because tools like Wikimetrics, Replay Edit, CAT-SCAN, ClueBot are built on top of the API and the SQL databases. So they are basically tools that can do some things that the API and databases can do, but none of them can do all the things that the API and databases can do. So it can really pay to learn how to use the API and the databases directly without going through CAT/SCAN, without going through Wikimetrics. And it all depends on the kind of questions you want to ask. So, in terms of the questions we want to ask and how we're going to ask them, let's talk a little bit about our next session. I've titled it Becoming Wikimetrics because I wanted something that started with a B. It's going to be in late August. I don't have the exact date offhand, but that'll be posted on the Grants Evaluation News page and the Grants Evaluation Library Wiki Research Webinars page is today, because I know that information exists. And what we're going to be doing, so it's called Becoming Wikimetrics, because what we're going to cover in that lesson is how to kind of do some end-to-end data manipulation. Basically, construct a query against the MySQL databases, dump those results into a CSV file, and then read through that CSV file with the programming language Python, and then and then use Python to kind of filter those results and search through those results and create a new CSV file that has the stuff you want out of the other CSV file. So we're going to be doing the kind of thing that that Wikimetrics does. So hence Becoming Wikimetrics. We're going to be getting data from the database and exporting it in a format that is useful to people. So in the course of this, we're going to be covering a very, very few basic programming concepts. So since we'll be working with Python, which is a high-level object-oriented scripting language, we will be coding in a full-fledged computer programming language. But we won't have time to cover most of the concepts that are required to understand everything that goes on in a programming language, even one as beautiful and straightforward as Python. So I'm going to be covering a couple of the basic concepts for how to manipulate data in Python, but a lot of the responsibility for getting kind of the basics down, if you want to get the most out of the session, will be on you. So there's going to be some setup required if you want to do more than just watch me and listen along. Unfortunately, we can't be very interactive in these sessions because of the nature of this streaming. So I will set things up at the beginning of the session so that there are discrete tasks that you can follow along with if you'd like while I'm doing them. And if you'd like to do that, you'll need to do a couple things. One, create a Tool Labs account, and there's information on how to do that on the wiki page. Two, set up Python on your machine. If you have Linux or Mac, you're in luck because it's quite easy to access. You have Python on your machine already, and you just need to figure out how to invoke it and use it. And then you also will need to install a desktop MySQL client. So these are open source software programs that live on your desktop, connect to the Wikipedia databases once you have a Tool Labs account, and allow you to run queries from your desktop and get the data you want exported into a handy CSV file. And there are several good options for this that are, at least one of them is cross-platform, and that will be on the workshop page, rather the wiki page, Wiki Research Webinars. So to get yourself in a good space for this, and you've got a month to prep, there's some good basic Python programming courses on Code Academy. There's a link to that on the wiki page. There's some good MySQL practice on SQL Zoo and the W3C schools, and those are on the wiki page. And there's also some good kind of general syllabus materials and sample code and sample tasks up on this OpenHatch wiki page that I worked on for some data science workshops, which are basically a more interactive version of what we're doing now, that I worked on with Mago. And so those materials are in pretty good shape and should be fairly relevant and interesting if you want to move on to using APIs, using programming concepts, and playing with your own data. So also in the meantime, I'm building out this Wiki Research webinar. I think that's actually the redirect. I think the main page is Wiki Research Webinars. So please help me build out this page. If you find links or if you have tips that you find helpful and think other people who are working with data will too. And you can provide feedback to me on the talk page of that. And I'll be monitoring that and answering questions and things like that. If you need help with setup of things or have technical questions, then there are a couple other resources available because I won't be able to answer everybody's question personally. But I have some confederates who are usually pretty nice people who might also be able to help. So if you're an IRC user, go to the Freenode IRC channel Wikimedia Research, which is usually peopled with researchers, and you can ask questions there. And then there's also a public mailing list, Wiki Research L, which isn't very active but has good people who work on it and fairly friendly. So if you have questions about research, whether it's methods, whether it's tools, or even programming stuff, these are places where you can ask. Wikitech L is another good one. And then also we just have a general questions page at the program evaluation, the learning and evaluation portal on Meta. So you can also ask things there. And lastly, if you have particular research project ideas that you want to do or think or would like to get other people to kind of work on with you, you can create an Idea Lab idea for them, and you can also just post a new thread on the Wiki Research Webinars page if you think that other people might want to get involved with something. And once again, reminder to, if you could, please fill out the survey, which is available on the event page. And if you watch this webinar, because in doing these webinars, we also find ourselves sometimes with a lack of data. If you could, in addition to filling out the survey, could you just comment on the event page and say, "Hey, I watched," because were it not for the fact that I saw people RSVP, I might have no other indication that anyone is listening to me right now. So anyway, thank you very much, and have a few minutes for questions. So I'm going to be looking at the question board to see if there's anything I can answer in a moment. So no questions yet, but I'm going to be hanging out here with a live mic for at least for a few more minutes. So feel free to ask anything that you would like to ask. Okay, so I'm finally seeing some questions. So Ty asked, is there a list of open source tools for querying the SQL databases from a desktop? Yes, and those are on the Wiki Research Webinars page. There's two of them that I know about, one for Mac and one for Mac, Linux, and Windows. The MySQL the MySQL desktop app link is on the webinar page. And let's see. And as one listener pointed out, yes, you can also directly access the command line. And let's see. Someone asked, is the IRC channel a free node one or one from irc.wikimedia.org? It is a free node channel, and the link to it is on the Wiki Research webinar page. Caesar also asked, can we have a query for a user on InWiki in the last 30 days in article namespace? Yes, you can. You can find information about a user's editing activities within any time frame and in any namespace. And those are all the questions so far.
Thank you, Jonathan, for hosting this first webinar, and we're looking forward to the next ones.
Yes, thank you, Maria. And thank you all. Hope to see you on Wiki. Take care.